Today we're going to be solving inequalities involving absolute value. And one of the things you'll remember about absolute value equations is that they set up, to solve them, we set up two different scenarios. Absolute value equals positive, absolute value equals negative. And so we're going to do the same thing today with inequalities, in that we'll have to solve two different cases. Inequalities do present another change that we have to get used to, and so we'll do a couple of those problems. I want to go ahead and make sure that you get this in your notes, make sure you understand. We just talked about and or inequalities. Some keywords that we talked about. And means we're looking for the overlap of the graph, and or means that we're just going to graph it, right? We're just going to put the two graphs together, the compound graphs. We're going to put those graphs together, and whatever happens, that's our solution. Okay, so keep in mind, and overlap, or just whatever happens, right? Or we're going to put the two graphs together. And I mention that because with absolute value inequalities, here's what we have to know. Absolute value inequalities that have a less than, or we treat those like they're and inequalities. So when we graph a less than, we're looking for an overlap. Absolute value inequalities with a greater than, we treat them as or inequalities. And so we're looking for, we're just going to put the two graphs together, and whatever happens is what happens. So less than and, greater than or, and that's how we treat absolute value inequalities. So let's look at what that special case kind of looks like as far as setting up to solve an absolute value inequality. And so we're going to solve each inequality, and then we'll also graph the solution set. And I put up here at the top as a reminder, especially since we're going to do this first one is a less than, that absolute value inequalities with less than, we treat them as if they're an and inequality. So again, absolute value, we have to set up two scenarios. We have to set up two inequalities that have to be solved. And just like we did with equations, the expression in the absolute value doesn't change, right? So n plus 2 is not going to change. It's going to be n plus 2 wherever we put it. So one situation that we solve looks exactly like our original inequality, except we drop the absolute value bar. So n plus 2 less than 11 will be one of the scenarios that we solve. And then to solve the negative scenario, remember when we deal with negatives, multiplying and dividing by negatives, with with inequalities, we have to flip the direction of our inequality. And so that funny little rule happens right here, where when I solve this for the negative that's on the other side, I also have to remember to flip my inequality. Okay, so now that I've got our two inequalities set up, we can solve both of those inequalities. Subtracting 2 from both sides. Subtracting 2 from both sides. Remember that less than is an and. Okay, so this is my solution. M less than 9 and m greater than negative 13. So now let's see what that graph looks like. So here's my number line, and I know that I need to have a 9 and a negative 13. And so here's what, and I'm going to go ahead and put them together pretty quickly, but there's my 9. It's an open circle, and less than, right, shades in that direction. Negative 13, also an open circle, and it's going to shade greater than, shades in that direction. And so I think you can see that the overlap does happen between negative 13 and positive 9. And so this would be the graph of my solution. Okay. Now, take good notes. Notice what we've done here, and this next one is yours. So we set up our two scenarios, n minus 8 less than or equal to 2, n minus 8, flip the inequality and make the two negative. And so these are the two inequalities that you solved, and we're going to solve them. Okay, we're going to remember to treat them as an and this is my solution. Okay, I want to go ahead and graph that solution. And so let's find 6 and 10. Both of them are going to be closed circles because of the or equal to. And greater than 6 goes in that direction. Less than 10 goes in that direction. And again, the shading happens between the 6 and the 10. And to be fair, like it has to happen between the 6 and the 10. Now we're going to graph it. We're going to kind of double check and make sure that that happens. In class, we'll look at some ways to check and how to pick values and make sure that what we've done is correct. But a less than is an and inequality, and the graph should be an and inequality. Now I do want to go ahead and show you one of the special cases that happens with absolute value inequalities. And so here's another less than, and I'll go ahead and set this one up for us and work it. So we've got y minus 1, and we're going to set it up exactly like it looks. And then we'll set it up again where we flip the inequality and change the sign on the other side, right? It was a negative before, now we're going to change the sign so we'll make it positive. And then we'll solve these two inequalities. So y less than, add 1 to both sides, and y greater than, add 1 to both sides. And again, less than has to be treated as if it's an and. All right, so here we go, number line, and here's my -1, here's my 3. Okay, they're both, neither one of them have the or equal to, so they'll both be open circles. Okay. And then y less than -1 would shade this way. Y greater than 3 would shade this way. And we're looking for the overlap. And looks for an overlap. And I don't see an overlap, which means this one is a no solution. Okay. Now, one of the reasons this is a no solution, remember what absolute value bars do. Those absolute value bars take whatever is inside, and when it comes out as a positive number. And so when is a positive number ever going to be less than a negative number? And the answer is never. The answer is no solution. There is no value of y that I can substitute into this inequality to make this a true statement, because absolute value will never be less than a negative. So that's one of the special cases that you have to look for when working with inequality absolute value type problems. All right, now let's do one with an or, and again I'm going to leave the little note up here that says that absolute value inequalities with greater than, we treat them like an or. In other words, whatever solution happens, we graph it, and then we just interpret what that number line says to us. So we'll solve the inequalities and we'll graph the solution set. Now it's absolute value, so we still have to set up the two scenarios. And so one scenario looks exactly like the problem, and the other scenario, 3n plus 6, we flip the inequality and we change the sign that's on the other side. And so now these are our two inequalities. This is our compound inequality that we're going to treat as if it's an or statement. All right, so let's solve by subtracting 6 and then dividing both sides by 3. Okay, again, there's an or in the middle. Let's not lose the or. We'll solve this side the same way. Subtracting 6 and then dividing by 3. And so there's our statement. Okay, my problem went away. So there's our two solutions to the set. So let's grab us a number line down here. And here's 2, and here's -6. Both of these are or equal to's, so we're greater than or equal to 2, so that shades this way, and we're less than or equal to -6, and so it shades this way. And that's my solution. And with an or, this is what we more or less expect our solution to look like. We expect it to split and go in opposite directions. That's okay for that to happen. Okay? Let's give one to you, and you give one a shot. Okay, so you've set up your two inequalities. One identical to what it looks like with the absolute value bars dropped. The other one we did 2n plus 1, and we switched directions and we changed signs. And so now we've got our two inequalities. So let's go ahead and solve here. Subtracting 1, dividing by 2, and the same thing on this side, subtracting 1, dividing by 2. And so here's our solution set in greater than 3 or in less than -4. And here's, I hope, what your graph looks like. So 3 greater than, shades this way, -4 less than, shades this way. Okay. Now there's also a special case when we deal with greater than problems, and so I want to make sure you've seen that. And so I'm going to set this one up and solve it, understanding that it is a special case, but I still want you to see what happens here. So one time we work it exactly as we see it, and the other time we work it, we flip the inequality, we change the sign. Okay, so we're going to add 6 to both sides. We're going to add 6 to both sides. And remember that we're going to treat it like an OR because it's a greater than. And we're going to graph our solution. So here's 1, and we're greater than or equal to, so solid dot and shades this way. 11, solid dot and shades this way. And I hope what you see here, and this is different from the other one, the entire number line is shaded. And so this one is all real numbers. Like, that's the special case for this one. And so again, let's go back and look at the inequality, and we're taking the absolute value of an expression and we're saying that it's greater than a negative number. So when is absolute value going to be greater than a negative number? Always, because when I take the absolute value of something, it gives me back a positive number, and a positive number is always going to be bigger than a negative number. And so that's the other special case that we have to deal with inequality absolute value problems.